Okay, Unit 9, Objective 5 for Math 3 is on cross-sections and solids of revolution. So, in general, a cross-section is the intersection of a solid, so our three-dimensional object, and a plane, which is our two-dimensional object. You can think of a cross-section as a very thin slice of the solid. And so if we look at a tree stump, so this is our tree stump, a cross-section of a tree stump would be if I were to cut the top layer off again. So I cut down the tree and then I cut another top layer. So let me actually get a highlighter because that's kind of hard to see. Okay, so if I were to do another cut, right, a really thin cut to get a membrane and looked at it from a bird's eye view, so if I look from above down, then this is what I would see, right? And so that is a cross-section, okay? So it is slicing through a three-dimensional object, so our solid, by a plane, which is our two-dimensional object. And so if I look at this triangular prism, and I looked at its cross-section, this part right here, it would have a cross-section of a triangle, okay? And that would be if I cut parallel to the base, which is my triangle, okay? So how does this connect to our Unit 7? So, you know, why is geometry related at all to what we have been working on this semester? So if we look at this shape right here, this is a cone, right? And so in this chapter we've looked at how do I find a volume and surface area of a cone, truncated cone, you know, so I've been working with cones. And then in chapter 7, we looked at and we studied circles in chapter 7, and we studied parabolas in chapter 7. Okay? And you will look at ellipses and hyperbolas, you know, not this year, but next year as well. And so if you look at how are the circles and parabolas that we studied in chapter 7 related at all to our geometry unit? So this is a shape of a cone. Okay, and if I were to look at the cross-section of a cone, if I sliced it parallel, okay, I would get a circle. Why? Because the base of a cone is a circle. If I were to slice it at an angle, so if my plane was at an angle, then I get what looks like maybe the opening of a cave. But that cross-section would actually be a parabola. And so all four of these figures are called conics, where the root word comes from cone. Okay. So when we studied circles and parabolas in chapter 7, we were studying two of the four shapes of a conic. Okay? And so that's one little relationship with our geometric modeling. Okay? All right, so let's take a look at this problem here. So this is in our volume 2 book. This is actually, even though we're in unit 9 for math 3, this is actually our unit 10. Okay, so this is unit 10. I forgot to mention this at the beginning. And so in our books, this would be 10.5, so chapter 10, objective 5 in the Pearson book. And so I'm actually on, let's see here, page 778. So in your Pearson book, page 778, so chapter 10, objective 5. Okay, so describing a cross-section. So what is a cross-section formed by the plane and the solid at the right? Okay, so here is my cylinder, right? So this is a cylinder. And so the cylinder is my solid, and it's cut by this plane right here. So if I could take this top half off and look above, I would see that the shape I'm making is a rectangle. And now we have it at an angle, but that's to give it that three-dimensional look. Okay? So my cross-section would be a rectangle. So there it is, kind of drawn in. And if I did draw it to look two-dimensional, it would be like that. Okay. Okay, so now this is the got it on page 779. Okay, so for the solid at the right, what is the cross-section formed by each of the following planes? So a horizontal plane. Okay, so if I take this, so this is a truncated cone, right? So this is a truncated cone, so the cone would extend down to here somewhere, right? And we cut off the top. So a horizontal plane. So I can't draw the three-dimensional like they can here in the book with their drawings tools that they have. So instead of actually drawing, the plane, I'm just going to draw a line right here like this, and I'm going to say that. So that's like for A. Okay, so this line that I drew here is to represent the horizontal plane slicing through my truncated cone, and I marked it A to indicate that I'm talking about that. Okay, so if I were to slice this, so if I had, a knife and I could slice through this, and if I did another one that kind of was right above it just to take a little slice or a sliver, what shape would I get? And so this is a truncated cone, so I would get a circle because it's running parallel to the base, which is also circle. And I want to go ahead and draw that in, so I'm going to draw what actually looks more like an oval to kind of give it that three-dimensional look. Okay. So then if I have a horizontal plane, I would get a circle. So now for a vertical plane, okay, so let's switch that. So vertical meaning along like the y-axis, so I'm going to do a solid line this time. And then put a B next to it to indicate that I'm answering part B. So if I had a vertical plane that divides the solid in half. Okay. So again, I have a truncated cone, and I know that, so I'm going to turn it just a little bit here. So if I look at this truncated cone, I know that the circle on the top, right, base, has a diameter, right? So there is a diameter here. And the circle on the bottom also has a diameter. Okay. And I know the edges of the cone angle in. So that would be my cross section. Okay. And so I don't want to draw that in completely, but it would be this part right here, right? So something like that. And this shape is a trapezoid. So I have parallel sides. So these are running parallel to each other. Oops. Okay. And so that would give me a trapezoid. All right, question number 7. So this is our practice 7 and 8 on page 779. So draw and describe each cross section. So this looks like I have like a donut or a bagel. So if I think about when I cut my donut or cut my bagel in half and I open it up, what I see is I have the circle on the outside and then a circle on the inside, right? So there is kind of what my bagel would look like, and to describe it I would just say a circle within a circle. In question number 8, I have a cone, and I'm slicing it with a vertical plane, and I want to try to figure out what my cross-section would be. So if I look at my cone, I would go from the edge of the cone to the edge of the cone, and then across the diameter, and the base of the cone is flat, right? The diameter of the cone would be flat as well. So then I would get an isosceles triangle. So some students make the mistake because they see that this edge here is rounded, so they think that the cross-section would have a rounded bottom as well. And it really doesn't, right? There is no rounded bottom because if I think of a cone, it has a circle on the bottom. This is the diameter of that circle, and it's not rounded, it's straight. Okay, so that would be a triangle or isosceles triangle. Okay, so for this one right here, it says that we're working on a visualization here, which is tough for some of us to do, but we're going to do the best that we possibly can. So it says that a plane region that revolves completely about a line sweeps out a solid of revolution. Use the example or sample below to help you describe the solid of revolution you get by revolving each region about line L. So if we start with a plane region, meaning a two-dimensional figure, and we're going to spin it about this line. So if you can imagine that we're spinning it about this line, that's going to create a solid of revolution. So a solid meaning a three-dimensional figure, and it was formed by revolving, so revolution revolving about the line L. So I'm not sure if this is going to record very well, but I'm going to try to. So if I have a pencil or pen here, so I'm thinking of this as my line L, and I'm going to put just a Post-it note attached to that. So I have a rectangle, so let me flip it so it kind of mimics. So I have my rectangle, it's my Post-it note, and then my line L. Not exactly perpendicular, but it's just to get the idea. So if I were to spin this, I need to figure out, okay, what shape am I creating, right? That's what they're asking me to do. What shape am I creating if I were to spin that rectangle about that line L? And if I can do that, so they're saying this is sweeping out, right? Sweep out, meaning kind of like the shadow left behind. What shape would I create? Okay, and I would create a cylinder, right? So how do I draw that? Okay, so this is a little tricky sometimes for people to draw. So I'm going to kind of go through some steps here to give you a little bit of help. So the first thing I'm going to want to do is just mirror my image or reflect it, right? Okay, so mirror it or reflect it below the line L. So I have this rectangle here. I want to mimic it. All right, so I'm going to mirror it. Okay, that's all I've done there. And then what I want to do is I want to create ovals or ellipses. And that's just to give it that three-dimensional look. And then if you remember, that's the symbol for perpendicular. Okay, so I want to create ovals or ellipses on perpendicular segments to line L. So this segment right here is perpendicular to line L, so I'm going to create ovals, and that's just to make it look three-dimensional. And here's another one that's perpendicular. And some of you may do some shading or doing some dotted lines, but I just need to get the sense of, okay, that looks like a cylinder to me. Okay? All right, and then there's another part to this. So it says to revolve the rectangle about the line L, which we did. And we want to find the volume of the solid of revolution if the dimensions of the rectangle were 2 inches by 6 inches. So that means this rectangle is 2 inches by 6 inches. So this is before we revolved it, right? So the rectangle was 2 inches by 6 inches. So I know that the volume of a cylinder is area of the base times the height. The shape of the base right here is a circle. So if I want to find the area of that circle, I'm going to use the formula pi r squared. My radius is the same as the height of that rectangle, so I'm going to replace r with 2, and it was 2 inches. So then the area would be 2 times 2 is 4, and then pi square inches or inches squared. So the area of that circle was 4 pi inches squared, which is my area of the base. So my volume will be 4 pi inches squared times the height. And so this is a cone, or I mean a cylinder on its side, so the height would be the 6 inches. So 4 times 6 is 24 pi, and then inches cubed. And so that would be the volume. Okay. All right, so let's take a look at 23. So for 23, we're just going to find or draw the solid of revolution. So the first thing I want to do is I want to reflect this to the bottom, or mirror it. And then any perpendicular segments, I want to make an oval. Like that, okay? And so then that would give me a cone. So 24, same idea. I want to reflect my semicircle. And then now this doesn't have any perpendicular segments, but I still want to do something to make it look three-dimensional. So one of the things that we can do to make a circle look three-dimensional is to draw an oval through the diameter, and there's, you know, whichever way I want to do that. So I'm going to just do it kind of offset here, doesn't matter, right? And then I'm going to dot the back half. And that's just to kind of make any circle look like a sphere. And then finally on question 25, same thing, I want to reflect the image. And then any perpendicular segment, so this one right here, I want to put an oval on. And then although there's not a perpendicular segment drawn here, I'm still going to go ahead and put an oval here because I want to make sure that we understand that what we have is a cone with a cylinder. Okay? And that's it for objective 5.